5 methods are there. Instead of going in details of those who want to do the research, so there is a research, very vast research in case of the HNPT, those who are doing in the control systems. So there is a electronics controller, all the streams they are doing with respect to deep learning, neural, fuzzy. Just you can add the application of the battery related to this and you can go for the finding out the estimation. Okay. Now we'll start from first method, that is open circuit. Next. So open circuit means what? Open circuit voltage. So this open circuit voltage means a traditional way to find out this or to find out the voltage. The first equation which is there, that equation, open circuit voltage is a function of state of charge. Open circuit voltage is a function of state of charge. Okay. Now that function of state of charge or FSOC, inside that FSOC, what another things are have you included that you can add. Then it comes, that is open circuit voltage is FSOC, or in terms of time, if you want to write the equation, at that time the open circuit voltage open circuit OCV as a function of time is equal to A1 into SOC as a function of time plus A0. So here what is the difference? We are putting a function of time or T as a function of time as a open circuit voltage or as a SOC. Two parts we have added. One is A0 and second one is A1. So A0 is the voltage. A0 is the voltage here. That part up to that 1.35 open circuit voltage, whatever is there. So that is the A0. That should be estimated, that should be known, or that should be given by the manufacturer. So when we say a 0 to that, so that is A0 is there. And after A0, how much percentage we are going to find, or how much percentage, here 20, 40, 60 or like that, the percentage as per the T we are going to find or we are going to run. With respect to that, A1 comes. So that charge is going to add, or that count coulomb in that in that particular picture we are having. So this is the open circuit voltage traditional method. Where we are going to use, so details will not find related to this, or details will not go, or in details will not go related to this. Where we are going to use, okay, presently in case of the traditional use, this method is used, open circuit. Why it is used? That is, first reason, it is highly accurate, and second reason, that is the regression, linear regression is based on the practical regression model. So regression means what? If you know once A0 and if you calculate T, then you can go for the regression model or regression part. So prediction of how much after this time, how much charge will be there, how much SOC will be there. And third one, that is where the power applications are there, for that power applications this particular method is suitable. Okay. So widely this open circuit in the traditional way, or we are going to use regression model we can apply. Second, the accuracy of this is very high. And third, in case of the power application, the disadvantage, or why this method is not used in the commercial way, or commercial where they are going to use the in the commercial vehicles, because the equilibrium state of the battery we are not able to identify, which is must in case of the commercial vehicles. So that state or that battery state we are not. That's why if you are not able to identify within a certain time equilibrium state, that's why the SOC estimation, online SOC estimation or charge estimation is not possible accurately for this particular open circuit voltage. And the time required, last one is very important, charging discharging time required for these batteries is very high. Very high means what? If I use very large batteries, then it goes into about 24 hours. So that time is not in our hand. That's why this method is used. Very small applications are there. Suppose two-wheeler battery is there, I want to find out its charge, whether charging, not charging is there. There I can use. Four-wheelers are there some probably they are going to use, or cells in that chemical reactions are not continuous related to that, we are going to use for the test method. Next method which is there, that will be continued by Garism.
Hello, is I audible? Good morning.
Good morning.
Good morning.
Good morning.
Namaste.
Namaste.
So I am going to use the mixed language, Hindi, Marathi, English. So I think there is no any problem for Hindi, Marathi. All of you understand Marathi, Hindi. For estimation, we are discussing the estimation technique and estimation of SOC. So before going to see the SOC part, we have to understand what is meant by the state of charge. Charge means what? I think all of you know. That is, what is a charge? We are denoted by Q in coulomb, and that charge is going to store in the battery. So if I have some analogy with water tank, the flow of water is nothing but current. And how much is water depositing in that tank? That is nothing but the charge in case of battery. We are storing charge inside the battery. Now, the problem is what? We have to calculate accurate value of SOC. For the electrical vehicles, those are running on the roads, and it is very difficult because online we have to estimate the state of charge. Whatever the methods we have discussed, that is conventional method, that method is applicable only at the lab work. So in case of the experimental setup, we can calculate the SOC. So in case of conventional method, what we require? Extensive lab work, and we require the charging and discharging cycles. One charging cycle is maybe of 3 to 4 days based on our accuracy. And so it will require much more time, but that methods are accurate. So based on the practical data, what we are going to do for that particular type of battery only, what we are going to do, we are going to estimate in real case. We are going to estimate the state of charge in case of the real vehicle. That is called as an online estimation. Online estimation means, you remember that we are just going to calculate the SOC on vehicle itself when the vehicle is running. That is the online estimation. And calculation of SOC means what? We are calculating SOC at lab work for that particular battery. Now, in any battery, the important parameter is voltage and current. So we have some graph. We are going to discuss that part. When I purchase new battery, assume that it is fully charged. I purchase a new battery, it is fully charged battery. And fully charged battery, the battery is indicated with the capacity, total capacity Cm. The battery has the capacity, total capacity Cm. For example, the Cm is suppose 100 mAh, milliampere hour. Milliampere hour. So suppose here it is 100 milliampere hour. 100 milliampere hour. So when we purchase the battery, it is having the full capacity. Assume that it is 100 milliampere hour. Now, as we use the battery, we know that the voltage is going to increase this like this. It means that when I purchase the battery, at this point you observe it is having the full of charge. At this point, it is having full of charge, so we can call it is having the 100% SOC. 100% SOC. And at this point, when battery is fully discharged, at this position, the SOC is become 0. Is it clear? Similar thing is offered to the current. Similar thing. Suppose I am taking this is O point, this is O point, this is C point, this is C point. बैटरी फुल्ली चार्ज, बैटरी को चार्ज किया है, मेरे पास इलेक्ट्रिकल व्हीकल है, उसमें मैंने क्या किया, पूरा बैटरी चार्ज किया, इट इंडिकेट द फुल चार्जिंग. जब क्या हुआ, आई एम जस्ट गोइंग टू ड्राइव दैट इलेक्ट्रिकल व्हीकल, और इलेक्ट्रिकल व्हीकल ड्राइव करने के बाद आई हैव वन पॉइंट. जब इलेक्ट्रिकल व्हीकल ड्राइव करते हैं, इट विल गोइंग टू ड्राइव द एनर्जी फ्रॉम द बैटरी, and I assume that the 50% energy is utilized. I assume that 50% energy is utilized. It means that 50% charge is released by the battery. Correct? When I utilize the 50% energy, it means that 50% charge is released by the battery. It means, in other words, that 50% energy is still remaining in that battery. It means that the 50% charge is stored in that battery. It means that SOC is 50%. In that case, SOC is 50%. Now, I am indicating that line where we are using the 50% of energy. Correct? The problem is that you can see here why it is much more difficult. You see this line OC and this is the 50%. We know it is SOC is 0%, 100% here, and SOC is 0% here. Here SOC is at this line 50%. Now my question is that where this line intersect to this x-axis? ये कहाँ intersect होगा? क्या ये OC लाइन के बीच में intersect होगा या कहीं और होगा? If you understand this, you understand the estimation of SOC. Yes, anybody? OC line, here is the OC line. At this O point, SOC is 100%. At this C point, SOC is 0%. And we are drawing one line there, the SOC is 50%. Now question is a very simple question. On this OC line, we have these 50% lines. Yes. Okay. Any other? I कुछ भी आंसर चलेगा. Majority of us thinking that it lies exactly in middle of OC. Correct? But it does not lie in the middle of the AC because we just remember when I drive the electrical vehicle, I utilize this path. This is utilize the path. I utilize this path. Already I have utilized it. It means that you can see their equation. It is integration of I dt divided by CM. It means SOC estimation is related with what? It related with this area under the current. We are calculating means what? We are going to measure the current. We have this current and we can easily calculate the area under this curve using integration. So we have means 50% energy utilized. We are here and this much energy is remaining and this is indicated by our meter. That is called as SOC meter. Whatever we are observing on mobile phone, जे काय मोबाईल फोनवर आपण बघतोय, the battery strength जे बघतोय, ती काय बघतोय, that is SOC. In laptop we are observing the SOC. Means this part is remaining here. We are interested in here. We are not interested here. We are indicating this part. And it is very difficult to indicate this part because we cannot calculate this directly, but we can calculate the current and area under current. And for that you can just see here. Now the total energy or total capacitance is CM. So total 100% in SOC means what? At this point SOC is 100%. Means this area. So suppose this is left hand side, this is right hand side. So if t is equal to 0 at this point, this is left hand side, this is right hand side. We are interested in the area of this curve. Similarly, you can see here, we are interested in the area of this curve. When I utilize 50% of energy, you can see here the